Hey, ladies and gentlemen. Sorry to miss you. Had to swim meet today, so I just wanted to share the information of how to do this project so that you guys aren't lost as we're rolling through this. So this is your equilibrium straw activity from the data that you collected yesterday. So the lab was easy, but the data collection was easy, but the data analysis needs to be thorough. All right, so that is the mindset that I want you guys to walk into this with. As we go through, the first thing that we're going to do is we're going to create the graph. So you guys grabbed your data yesterday. On your graph, I want you to make sure that you plot all of your points. The way that you plot the points is kind of up to you, but make sure that your axes are appropriate. Now, there's really two ways that you can plot it. One, this is probably my first choice, would be the thing that makes the most sense to me, would be to plot your trial numbers on the x-axis, and then you have two separate volumes, so that would create two separate lines on your y-axis. So trial one, you'd have 0 milliliters and you'd have maybe 25 milliliters, whatever your volume was. Or your other option might be to use your two different milliliters reactants and products and plot those two together or against each other as your XY pair. And then think about what that line might represent. Maybe a little bit more difficult, but you could also use that as well. Make sure that you put your X and Y axis are clearly labeled, that your scale goes all the way up to cover the whole graph, right? It's not this tiny little graph in the corner. Those are the things that you want to watch out for. And then at the bottom of it, bottom of your graph paper, you need to give a description, kind of like a caption that you would find in a textbook. All right, big idea for this whole lab. Just read the screen. It says, for natural and built systems alike, conditions of stability and determinants of rates of change or evolution of systems are critical elements of study. So we're looking at how things change. Here's a great example from outside of chemistry. Yesterday, President Biden released 180 million barrels of oil. What was the consequence? Well, today, if you drive past California and Oak Street, the Chevron is 20 cents gas, is 20 cents cheaper than it was yesterday. Yesterday it was $6.19. Today it is $5.99. So that's a consequence of it. Is that going to stay the same? Is it going to continue? Is it going to go to rise back up? Will it continue to fall? That is to be, found out, right? But what we do know is the conditions changed, and so we ended up with a change in the system. Where that comes to equilibrium, we'll find out here in the next few days, won't we? But this is a big idea, guys, that's not just chemistry related. Chemistry part that we're doing today helps you understand these rates of change and how things can change and then come back to equilibrium so that you can apply those things to the other parts of your life. All right, so here's what you're going to do. First, you made your graph, right? And now you're going to do some writing. So I want you to describe your experiment just a little bit. It doesn't need to be long, but you do need to talk about which straws you used. Did you use the white straw and the red straw? Was it the white and the black straw? That is really important because they have different diameters. The diameters are here on the screen. And so you guys can use those diameters in order to show, hey, we had this diameter, that diameter, and then talk about how that affected your equilibrium point. All right, as you go down, you'll notice that you're in number 3, you're going to be supporting that claim using actual numbers. That's really important. I have been talking about this all year, and I've seen little evidence of you guys using actual numbers in your data. It needs to happen every time. Now, here, number 4 and number 5. This is in, I guess, number 6. This is where it gets a little bit more tricky. So what is the relationship? So if you had the big straw and the little straw, or you had the white straw and the black straw, what's the relationship between the size of the straw and the amount of fluid in that graduated cylinder when it reached equilibrium? So did it just stay the same? Did it matter which one started with more, or how did that change, right? That's what I want you guys to talk about there. Now, there are 4 different straws I have up there. We have a green straw too. What if you had the green straw? The green straw is much larger in diameter, 3 times larger than any of the other straws. What if you had that straw, right? How would that change your overall dynamic in terms of where your equilibrium point might be? Would it get there faster? Would there be more fluid in the container that has the green straw, or would there be less fluid in the graduated cylinder that had the green straw? If, let's say, for example, you had the green straw, right? Okay, so let's finish this guy up. Now, this whole assignment is actually a critiquing assignment. You give one, you get one. So it has nothing to do, it has a lot to do with your lab, but you're getting graded on your critiquing. So on Monday, when you come back to school, you'll hand in your lab. I'll pass those labs back out to people, and then I will, the people that turned them in, remember, get one, give one, get one. So the people that turned them in, you will get a paper back to do your critique, and that's what we're going to do on Monday. So your critique looks like this. First, you're going to evaluate, hang on, wrong slide. These are the ideological points. So this comes from your science and engineering practices. You guys can read the screen, but we're going to evaluate the claims, right? We're going to look at their evidence. Does the claim match the evidence? That's really important. And then the second point, I'm going to go ahead and read that one. Respectfully provide and or receive critiques on scientific arguments by probing reasoning and evidence, challenging ideas and conclusions, responding thoughtfully to diverse perspectives, and determining additional information required to resolve contradictions. So we're going to provide a critique in a thoughtful way that's not going to obviously be demeaning to anyone. And that's your job. That's what you're supposed to be doing. This comes straight from your standards, ladies and gentlemen. So think about this as we look at our next slide. Yeah, you're going to evaluate the person's data, and then you need to evaluate the person's argument. So this is where you guys have some wiggle room, and I want thoughtful critiques, right? Did their data match what their claim is? Did they actually provide data to go with their claim? Did they provide more than just a little bit of data? They explained why it was supposed to happen the way that it did. And then finally, did they expand upon it? This is where you're critiquing if you agree with their argument or not. And so this is all about the critique, guys. So I wrote the assignment. The writing assignment was written so that you guys can do this critiquing activity. So it should work out really well for you, but I want you to do a great job. And as you pass off this somebody else, think about the ideas that they're going to be critiquing you on, so that you do a good job on those so that they can provide you with a good critique. All right. So I'll be happy to answer any more questions on Monday, but you guys need to be ready to go Monday. And we really won't have time to finish up because we are planning on actually doing the critique. All right. So send me a question on Remind if you have questions. Otherwise, I hope you guys have a great weekend. Bye.